Alrighty guys, welcome back to the beginner Altium tutorial that I'm doing. This is part 2 with it's that from idea to manufacturing or something like that. I forgot the name. Just look at the title, it'll be the title. It's that project. So we're in part 2 now, so we finished up the schematic in part 1. And now we're moving on to all of the PCB stuff. I just went and checked ahead through kind of what we're going to be covering. So it'll be stuff like anything related to like the layout itself. So the board size, some of the routing stuff, some of the design rules stuff. So there's a whole host of things. I mean, for context, like the PCB layout, like there are entire professions dedicated to, being an expert on just the routing and the layout stuff. So it's a very complex topic. So there's just a lot of information there. So yeah. So without further ado, we'll get right into it. So I'm at the part where it says creating a new PCB. It says before you transfer the design from the schematic editor to the PCB editor, you need to create a new blank PCB and save it as part of the project. Right. So you just do. You can right click here and you add new to project, and you just go PCB. Alright, so here's a blank PCB. We'll do is we'll right click, we'll do rename, and we'll do multi-vibrator. Multi-vibrator. Unable to save file, and I don't know why it's saying that again. There we go. Maybe it's because I didn't do a save as. I'm not entirely sure. Hopefully we'll get that. I haven't closed this and tried to reopen it to see if it actually has any effect. Yeah, so I can right click and save the project as well. So maybe I'll try to open and close it some other time. Who knows? But okay, so here we have our blank piece, our blank canvas, if you will, right? So we can zoom out, zoom in. So I would say again, like read all the information that they give you, all the little drop down thing, like for example, the little arrow you can click that says adding a new board to the project. I'd say read everything. It's all valuable. I'm just kind of skipping over some stuff, and I want to save time and highlight stuff that I think is important. So anyways, so what it says is it gives us a couple tasks. So I'm in that little task table, right? So it's configuring the board shape and location. So the task is set the origin. So when you set the origin, you just go edit origin, and you just go set. So what this is right here is this is our current origin. All right, one thing I guess I'll cover real quick too is, so I don't like how the resolution of this is, in the sense that like I can barely move my mouse and there's not like a nice little snap grid. So what I'm gonna do is I'm gonna click G, and then I'm gonna go to 100 mils. So you see how it's snapping a lot. I'll call it like a lot lower resolution. I really like that. Because things that drive me crazy, right? It's just things being like 1 mil off in some direction. So that's just what drives me bonkers, right? Because like let's say I had the snap grid at like the 1 mil, right? And I put it like right here or something like that, right? So when you zoom out, it doesn't really look that. It'll drive me crazy. So 100 mil in it will be okay. So boom, new grid's right there. This is not really that critical for like routing or anything like that. I think it only matters for getting an accurate board shape, right? And then it says the next task is set the units, imperial or metric. So let me see what it's talking like. Okay, so if you see, I click Q. We're still on the 100 mil snap grid. So effectively everything is the same, and now it's just giving us that reading in millimeters. Okay, one thing I will say, never in a million years should you, from at least in my limited experience, would you be snapping between mils or metric and imperial units on the fly in the middle of your design. I can't think of a reason why you want to do that. In fact, from my experience, like the grid and the sizing really matters a whole lot when it comes to pieces, because you're trying to get things fitting into the tiniest little spaces you can, save as many inches you can, because all the time when you're on a project, space is always limited, right? Like think of like those. Imagine being the poor PCB layout guy who has to do those Apple AirPods, right? Those things are this big, right? Imagine like something being 1 mil off on one of those layouts, right? Like it would just you would cost Apple billions of dollars. Is what I'm saying. So so that's why like consistent like space matters a whole lot. So I think toggling around is just asking for you to mess things up, right, on clearances and stuff like that. So I'm pretty sure you're always going to be in the same snap grid. I can't think of a reason why you wouldn't be. So yeah, it says select a suitable snap grid. Again, this is a very simple board to route. Like we have almost too much space to work with, so we're not like we're making the Apple AirPods, so we don't need to be down in the trenches on the 1 mil snap grid, So when it says a suitable one, I mean 100 mils will work. Maybe we'll go to 50. It depends on. We'll see how this pad spacing is, right? Going to 50 might work again because my OCD we'll see where it kicks in other places. So I can bring up some more examples. The next thing we do is redefine the board shape. So right now it says the default board is 6 inches by 4 inches, so that's like 6,000 mils by 4,000 mils. Real quick, I can show you a little thing. So it's very weird. You can measure distance in this. It's a very useful thing to do to measure distance. And I don't know why they do it this way, but the way I've learned to measure distance, maybe there's another way to do it that makes more sense. 'Cause it's just a weird place to put it. Because you go to reports and measure distance. Like it's just a weird thing to do. A weird place to put it, right? Because it's a report and I don't get it. So you just click and you drag, so we're going from one corner to the other. And so as you see, it's 6,000 mils by 4,000 mils. So that's 6 inches by 4 inches. So I think if you click again, like it gives you this distance and it populates these things. I'm not 100% sure like how to get rid of this stuff. It's kind of annoying. All I do is hit like Control Z. Okay, that's not working. Usually it would work. Okay, so Control Z is what I used to use to get rid of that stuff, right? Because I don't know, this is annoying to me. Let me see if there's a way to measure selection. No, measure distance. Reset error markers. That's not what I mean. Because I don't want this here. I don't know how to get rid of it actually. So I promise I've done it. I promise I promise I know how to do this stuff. Okay. But this is annoying as shit. Whatever. Okay, we'll come back to this if we figure it out. So anyways, what we're going to do is it says redefine the board shape. I think we go to view. So there are 3 views in the PCB layout mode. There are 2D layout mode, 3D layout mode, and board planning mode. So right now we're in 2D. The 2D layout mode is used for the actual drawing of the traces and routing and putting ground planes in. All that stuff. You spend most of your time in 2D layout mode. 3D layout mode is for you to sit back and marvel at the wonderful piece of work you've done, see all the beautiful components populated in their respective places, and just go, wow, I'm such a good engineer. Look, who could have done it better? Nobody could have done it better. Okay, and then board planning mode is literally just you'll use it right off the bat, and it's all it is for defining the board shape. So, let me see. There might be. What else did you do? Was it edit? I can't remember exactly how I designed. Okay, yeah. So, we have some options here. We have redefine board shape, edit board shape, modify board shape. I don't know what the difference between edit and modify are, to be honest. Like this is such like. I mean, I don't have enough routing layout experience to know if you will ever be changing the board shape like in the middle of a project. And I could definitely see that, like where you think, oh, I need this much space, and then it turns out you need less, and you're like, well, of course you're gonna ask for less space if you can give it to them, right? So then you might need to modify it after you've already drawn some stuff. So that's when things could be useful, right? And having to modify it. But since we're already starting, we know exactly how big the board can be. Another thing too is I think what I would imagine is like, say you're the layout engineer, the PCB layout like designer, is they say, okay, look, we have 30 millimeters by 30 millimeters of space for you to work with. you're going to take all that space and you're just never, even if your board can fit on smaller, you're still going to keep it bigger, because let's say something happens where you need to change it in the future, right? Say a component goes end of life or something like that happens where you need to make changes. I feel like it'll be a lot harder to fight back for that extra space. So you might just keep the extra space and just leave some, unpopulated territory on the board. I can imagine that. So, I don't really see too many use cases for modifying board shape after you've already started the project. So anyways, let me see. A redefined board shape is what we're going to go with. But first, we're gonna do it. We're hitting Q, baby. We're going to millimeters, because it says 30 millimeters by 30 millimeters. So now that we're on the 1 millimeter snap grid, so we're gonna zoom all the way into our nice origin. Okay, so this is like this triangle, I don't know, it confuses the hell out of me. So just ignore it. We're only drawing one side of the board at a time. So just know that if you look at the Y, okay, we're at 30 millimeters, right? Now we're gonna go over X, we're gonna go over 30 millimeters. Okay, so we're at 30, 30. And then we're going to go down in a straight line. So boom, right there. And I'm not sure if we have to click back on the origin or not, but I think we do. So we're going to right click, boom. Okay, we're out of, so this is our new board shape basically. So now that we've done that, so we redefined our board shape. Let's just do a quick, if you look at, I wonder if it's gone now. Here, we'll go back to view and do two. Yeah, so that little measurement thing that I couldn't figure out how to get rid of is gone, but that's not what I want to see if I can measure in this mode actually. Measure distance. So we click in the corner, and so what I was going to say is that problem I encountered where I couldn't get rid of the measurement report afterwards. What I do is I just don't click. I just look at the corner. If you look at the top left of the screen, it says 30 millimeter by 30 millimeter. So we're good to go. Then you just right click and then boom, it gives you the information you need to know, because you don't really need to have these reports posted necessarily. Like occasionally, like I know if you're sending the design to manufacturer, you need some measurements posted on here would be helpful, but it's not 100% necessary. Okay, so now that we redefined the board shape, we are going to go back to this view, right? The familiar view where we started. And let's see, so the last one we do is configure the layers. So okay, so it's just talking about configuring the layers. Let me see if we can go. Where is that? Layer stack managers. This is what it's talking about. I don't know if it. Let me check. I'm not sure if this is what it. This is not exactly what it's talking about. This is sort of what it's talking about right here. Okay, so yeah, what I clicked on, I don't know how to explain the difference between because you could both refer to these as like layer stack managers sort of, but if you look at all this, these are just the way, since these PCBs are, if you don't know, they're like a nice layer cake. So you have like, silk screen, and you have like solder mask, and then you have like maybe a signal layer. And then you have underneath that signal layer, you have some type of dielectric material, some type of insulative material, or some type of, structural material that actually makes the PCB its nice wafery, crispy, shape. And then below that, you'll have like maybe a power plane or a ground plane or something like that. So that's what this part is referring to, right? So you have like this board right now is set up as 2 layers currently. We might change that in the future. I'm not sure what the tutorial asks us to do, but I'll definitely be showing projects maybe with some, multi-layer boards where there's more than one, more than two. Sorry. What I don't get is, so this is top layer T. Oh, bottom layer B. Okay. So, yeah, that's what this is just referring to. Is you just have all these little layers to you can toggle them on and off. As you please. It just helps with the neatness and routing things graphically and stuff. So, so that's kind of what this is for. So if you hear it like mention things like silk screens and solder masks and stuff like that, that's what this is referring to. All right. So we already refigured. Okay. Blah, blah. I want to see. Okay, so the next thing I'm at is. It says configuring the defaults. Yeah, okay. Okay, so it's talking about like vias and stuff like that. Okay, don't worry. Alright, so the part I scroll down to now is transferring the design. So it says the design is transferred directly between the schematic editor and PCB editor. There's no intermediate list file created. Okay. So what we want to do is go back to our schematic and click Design, Update PCB Document. So we'll do this. So this gives us like a little engineering change order in here. So there's a part I want to mention here. I don't know, it kind of mentions it later on a little bit, but I'll just focus. So down here is this add rooms thing. So this only exists to be annoying. I'm pretty sure. Like that's literally all it does. It's really, really annoying. It's referring to a design rule, referred to a concept they call rooms. We can get into it later. It's all you need to know is it's annoying, okay? That's the important part. So what we want to do is we're going to validate. I want to see what happens. I'll even go in so we're executing the changes. So what it's doing is doing all that. Okay. So what happens is boom, here's all our beautiful footprints for our components. Like what we're looking at right now, like see that resistor is it has oh, interesting. Oh, maybe because that. So if you look at that resistor, just think about how it had one side connected. Okay, here, we'll just go to the schematic and understand what. So these are like the pads of the resistor, right? Think of it when you remember you see your typical resistor in your labs, right? They're like the through hole kind. You just have like one pin, another pin, but these are like called surface mount resistors. Same exact concept. You're looking at one pin and another pin, and that's what these are representing. So the annoying part that I'm talking about is this little red box. This is called a room, and okay, if you see, if I click and drag the room, everything's inside it. That's not really what the room does. We'll get into what the rooms are some in a later video maybe, but they're annoying. Okay, so what we're gonna do is go to the design rules, and I want to find room definition. Wow, I found out room definition. Okay, so we're gonna disable this rule because it's annoying as shit. Okay, so that's what I need to know. If you want to get rid of room, it doesn't do anything functionally. It doesn't change your design. Don't worry about any of that. It has nothing to do with electrical engineering. Okay, and most of other engineering. Okay, I don't know why they made it. I mean, I do know why they made it, but we'll get into that later. Okay, anyways, so we're just gonna fiddlesticks. Alright, let's just try update. No differences detected. Well, the room was gone. That's the difference I'm trying to get it to acknowledge. Because, okay, you can also delete the room too. That's what I was that's what I wanted to do. But I wanted it to where every time you compile the PCB, it doesn't create a room. Because it's annoying. So, anyways, but the room's gone. That's all I want to do. So, say, if you want to figure out how to get rid of rooms, because you don't really know what they do. Like, I know what they do, but because they don't really serve any purpose. That's how you get rid of them. It's just disable that rule. You can even delete it altogether. I do think Altium has like a default setting where the rules will, like, every time, if there's no rule like under a certain category, I think it just populates it with the default rule or something like that. So just know you have just leave the rule there, but just disable it. Okay. So here we are looking at our beautiful footprints. Yeah, and okay, these little lines are referred to the entire collective group of lines going every which way is called a rat's nest. The reason we have lines going each way is because it's telling us which pins need to be connected where. It's very convenient whenever you're routing things. when you're in the weeds trying to route stuff, it's very easy, nice when you have like a nice little straight arrow, straight line going from what pin you're at to which pin you need to be going to. That's why that's there. But yeah, it just looks really messy and stuff like that. That's why they refer to it as a rat's nest. So as you can see, our PCB looks pretty similar to what the project is saying right now. Alright, so now I'm going to the configuring the display of the layers. Okay. So yeah, so it's noting that we're looking from the top down. If that wasn't obvious already, we're looking from the top down, guys. Not sideways. So they do have a pretty nice graphic, if that helps explain what's going on. If you scroll over that picture, where it gives you like a top down, but then kind of like an angled, more like graphically rendered version. That's a pretty good explanation of what's going on. So yeah, it's giving just, yeah. I was talking more about the layers. I feel like the layers need to be, like the way it goes into layers, like it briefly explains it, but I think they deserve their whole entire other video, and we can talk about them at length for hours. So I'll probably do that. Because right now I'm sure all you care about this introductory project is literally getting those sweet output files where you can send them to a PCB manufacturer, and then they tell you it costs $600 to get one made, and you're like, how does anybody do this? You know, it's like these literally we have like 8 or 9 components. It's like $600. Like, no, thank you. Anyways, so yeah, I mean, it gives, like I said, read all this stuff where it's explaining about the layers and stuff like that. It's good to know. I mean, you're gonna have to learn it eventually, and getting your feet wet with this stuff is very helpful, I would say. But don't think this tells you the whole story, I should say. So yeah, it's talking about the layer stack manager. Okay, so the layer stack manager is this section. We'll say sure. I don't know really. Yeah, and again, the layer stacks themselves. We could talk for hours about the different weights of copper and the thicknesses and the dielectric constants and all that. Like, yeah, I just want to say this is like the tip of the iceberg. Let's see what it says. Doesn't. Okay, is that what it's talking about? Yeah. So CF04 1 ounce. Yeah, so that's also CF04. I think it automatically changed this one. Let me check and see if it did. Yeah, so it changes them in pair, because the one thing that's important to know, this is, you probably won't understand when I say this, but the board needs to be symmetrical in terms of like the thicknesses and the weights. Think of it kind of like a sandwich, right? You gotta have, it's got to be a little bit symmetrical, or else bad things happen during manufacturing. That's all you really need to know about that. That's why they change together. So I don't think it'll ever let you make a board that's not symmetrical like this, where the weights are the same on each side and all that stuff, right? Because it's like whenever it comes down to manufacturing, they do this thing called like a frisbee test, right? Where they just huck it down the hallway, right? And if it doesn't the gyroscopic forces aren't in alignment, then they're like, this is no good. We got to get rid of it. It's called the frisbee test. I was completely making that up. There's no such thing. But what really happens is it gets because these boards go through a whole bunch of sequences of heating and cooling. And so you think about when metal heats and cools, it expands and contracts. And if the thicknesses on the boards, on the sides of the boards aren't the same, then you're going to get like warping to your board. And then it's going to come out and it's going to look, it's not going to be like a frisbee, is what I'm saying. And you want it to be like a frisbee. So I don't know why it's talking more about configuring the grid. Again, this is so dumb. Okay. Suitable grid settings for as much design as... Okay, so I don't know if I just skipped over the parts where it's talking about design rules, but it gives you these tables of design rules. So for design, just simple. So it says the simple tutorial circuit, a practical grid and design rule setting should be. So there are some good things we need to change here. So the routing width, 0.25 millimeter routing width design rule. So this is referring to as the width of the traces of your traces that you're routing. And I'll point them out whenever we see them exactly, so you know exactly what I'm talking about. But for now, we're just going to go into, what is it, design rules. And we're going to go to the routing section. And the width is what we're going to look at. And let me see. Preferred width is 0.25 millimeter. Okay, no. So these are, I like this. This is a very elegant way to explain what the hell's going on. And it says the routing width is 0.254. And I don't know if they just chopped this off, but the way it works is you just go 0.250. That's what I'm gonna make. I don't know. They did. I don't know why they did that, but I'm just gonna change these all to 0.25 because I don't know if they just chopped off a decimal place and they really mean 2.254. It doesn't matter. All right, this tutorial board. We're just trying to get through this process, right, and not make it on the other side. Okay. So 0.25. The next rule we're gonna check is clearance, and I don't know, routing. It's an electrical design rule. Okay, so we're looking at clearance. I mean, we can read this. I don't know if it tells you exactly. Okay, so what this one is explaining. Well, I guess I should have elaborated. I'll go back to the routing one. But again, the width, the rules themselves, you can make an entire video on just a couple. It's like there's tons of, I think there's like over 100 rules. Some of them are very simple. Some of them are very complicated. Don't worry. But if this diagram wasn't obvious, this is the width of the trace we're talking about. And so it's asking us, what is the max width of the trace? What is the maximum allowable width of the trace? What's the minimum width of the trace? We could talk about why this matters in terms of electrical performance and in terms of manufacturing. That's for a later video, but just know that's what this means, is how wide your traces can and should be. So without further ado, back to the clearance. It's the same concept. Here is what it's talking about here is you have the clearance, which is just between two other pieces of like copper. So in this diagram, it's showing you the clearance between a via and then a routed trace, but this could be between, you know, another trace, or they call them tracks. Traces, tracks. That's synonymous. That's what I mean when I say trace. So here it's talking about track to track. This is just a table with this is all the options you have when you're routing stuff. These are all the things you can come in contact with in terms of, like, you could have a track that is close to a pad, or this is a surface mount pad, this is a through hole pad, this is a via, this is copper. I think this means like a plane. We'll get into those later, don't worry. A plane, just a large open sheet of copper. So if you see, we have the table here, minimum clearance. It just says, okay, this is a little in simple mode. I want to see, there was a way to name clearance comment. Okay, I think there's a way. Yeah, so the minimum clearance 0.25. There we go. So it is letting us edit it, right? So if you see, I just clicked that. The way they let you do is you can click put one number up here, and it automatically changes every single one there. For some reason, like, there could be cases where you want a clearance difference between some of these, but for the purpose of this tutorial, we're just going to do 0.25 millimeters. And I put the mm after as well. I think that changes it to millimeters, and I think you put mil for mils, and that's how that works. So board definition grid, I don't think that matters because this is like a preference. It doesn't matter. It only matters for how your preferences are and how you like routing, right? And I said I'm very OCD, so we're going to do, you know, these big ones or whatever. Same thing for the routing grid. Same thing for the component placement grid. These are all just preferences, ease of use. Via size and via hole, so that matters. These are routing via style. So routing, and then we go to via style. So routing vias. So minimum hole size via hole, we'll just go preferred is 0.6 millimeter. And I'm sure that's going to throw back an error or something because the minimum is lower than that. 0.6 millimeters. And then we'll just go 0.6 millimeters here. And we'll get into, it's important to understand how vias are actually made and manufactured in order so you can understand how to design them well. So we'll get into that later video. It's very complicated. I mean, it just has a lot of steps in it, and understanding all the different, just intricate understanding. So yeah, let's see, 1 millimeter. We'll go with 1 millimeter again, and then we'll just go 1 again. Okay. So this is the via diameter. I think that's what I was talking about when it says size. Could have been talking about radius, but usually it's talking about diameter. Okay, so we got those settings changes. Okay, so now we're through that table. We're past that. Then it talks about routing multiple grids. Never have I ever done anything in polar. I mean, maybe that AirPods guy who's routing a circular board, maybe that matters to him, but never have I ever done that. I'm sure it's really expensive to do that because nobody does it. So they probably don't have a lot of machinery that can handle that sort of routing, but I don't know. Yeah, I don't really think the snap grid is rules. Setting up the design rules. Okay. So it tells us to add a second rule, but I just changed the first one. Okay, so what they talk about, the scope. So yeah, we'll briefly touch on scope for this stuff then. Okay, so that means we'll do design rules. So the scope is basically the way rules are done in Altium. What is this? Width. So is if you look at the scope is all. So that means every object on the board. So all of the components on the board are going to be, all the traces on the board are going to be analyzed using this rule. So what you can do is you can change the scope. Let's go. How do I go back? Because there's like a way to scope. I don't know if there's a way. I don't know how to priorities. We'll type with scope all. Maybe it'll tell me how to edit the scope. I guess, oh, maybe what it's saying is if I only have one rule, the scope has to be all. So let's try a new rule and see if we're, okay, so here's the scope up here actually. So let's just go back here. Okay, we're gonna delete, I right clicked and I'm deleting rule. Oh, what I think I messed up though. I wonder if I can fiddlesticks. Well, I think I don't know what I did. Okay, don't worry. We can fix this. Don't worry guys. Anyways, what I was trying to go through, and we can change the name. We'll just change it back to width. I don't know why it's doing this. Oh, it's because it has the same name. Okay, let's just hit apply. Yeah, okay. No. Let's go back. Okay. Okay, so here are here's that. We can go like net class, and then we go for net, and then we have here are all the nets in our project, right? This will be a drop down list of all the nets we have. It's telling us to do it to 12 volts because this is like the power traces it's trying to apply to. So the other one's gonna be smaller, I'm guessing it's saying. So, anyways, now that we got through that catastrophe. Oh, we can say Okay, wait. So it says power or ground can be in that net. Okay, let me see if I can show you how to. Because there's a way, because a custom query in net 12. So this is more like, it's very computer sciencey. I don't really know the language that they're talking about, but and I'm just making this up as I go along. Like I literally never done this. Because these are called like custom queries where you do like computer sciencey stuff like this, and so basically I just did what it asked, right? So in net, so this is saying if it's in the net, the scope applies to any of the components that are in the net 12 volt or any of the components that are in the net ground. So that's what that means. Again, we'll do custom queries in a later video when I learn more about how they work. I mean, literally, it's just understanding the language that they use and how to actually code it, so to speak, because you can do some really fancy stuff with this custom queries. So but I would say for this tutorial, do not worry about it. It's just showing you, all it is trying to tell you is that exists, that's a thing you should be aware of. Maybe go learn more about it. Alright, so right now I'm scrolling past all the stuff that I went ahead and straight up did everything, and it's just showing you the detailed explanation. If you just scroll through defining the routing via style, and then above that one is defining electrical clearance constraints. So you can just, that's the stuff that I just went and did. But I would say read it all. I might not have covered something that would be helpful to know. So yeah, now right now I was talking about existing design rule violations. You might have noticed that the transistor paths are showing there's a violation. So that's why these are green. That means error, which is not very intuitive at all. It's because the way you see it's an error is you have to zoom in all the way down to they're really little X's. That means error. So right click over violations, select the violations in the right click menu shown below. Details show that there is a, so right click, and what does it say? Right click on the violations in the right click menu. Violations. Clearance constraint 0.22 millimeters is less than 0.25 millimeters. So somewhere, if you remember, actually, we set that clearance constraint to be 0.25 millimeters. It actually told us to do this. I don't know why. Because we have an error right now, right? So what it's saying is that we have two pads that are less than 0.25 millimeters away from each other. And what it's talking about are this pad right here and this pad right here. They're saying they're too close together. And I don't know if this is obvious or not, but we can't change how far apart these pads are because they belong to a component whose manufacturing, like its properties are set in stone. So we have to change our design rules. That's what it's saying. So what we want to do is, it looks like, here we'll go in and we'll check the exact rule. So it's the clearance constraint, okay? So I don't know if it gives us a fancy way to component clearance, because what I wanted to see was, because it's, what I'm trying to say is the rule that we have in place is useful and has utility, and there's good reason for it to be the value that it is. However, you can call as all rules have these exceptions. So this case would be an exception where you want the rule to be applied other places, but you don't want it to be applied here. So I want to see if there's a way. I mean, we can do things like with the scope thing, the fancy scope query thing, where the rule doesn't apply to components or to pins or pads that belong to one component, but everywhere else is still valid. And I want to see if there's an easy way to do that or if it's difficult. So again, it's component clearance. Okay, so electrical routing. What rule? No, what rule is that in? Clearance. Okay. Except for if we go to design rules, so what it's saying is component clearance right here. And the scope is all. We need to make this a little bigger. Okay, so if you see, this should look similar to what the picture is showing in that tutorial, like in a Altium tutorial. So horizontal clearance equals 0.25 millimeters. Vertical clearance 0.5 millimeters. I'm not really sure if we're just supposed to disable this or change the, I mean, one way to get around it is literally just to change the value. Right, because, so if you look at this exact value it's SMD pad to SMD pad. Oh, okay, I mean, here, we'll show an exact. So SMD pad to SMD pad, so we'll hit apply, okay. So you see it's still green, but what we need to do is, what is it, reports? Or is it, no, tools, design rule check is what we want to click on. Run design rule check. Okay, don't worry, we got a bunch of errors, just don't freak out. And it generates this little document for us, but don't worry. Okay, that's still like that, and I don't know why that is. Let's see the violations. Okay, it says point lesson between pad on multi-layer and multi-layer. Okay, so I don't think I modified the correct rule. So maybe it's, oh, it could be through hole pad as well. We need to modify. So SMD, so these actually might be through hole pad. Through hole pad and through hole pad. Right, because this is a transistor, if I remember correctly. So I think what I did wrong was the transistor is a through hole component. And I modified the SMD pads, right? So what we're dealing with are not SMD pads, we're dealing with through hole pads. SMD, we're surface mount, right? We're not dealing with surface mount pads, we're dealing with through hole pads. So through hole pad to through hole pad. Let's try that. Boom, it went away. We're engineers, baby. Okay. That's how we do it. Now, don't worry about those other errors that threw up at us. It's just trying to protect us. It's trying to do what's best for us, so don't worry. All right, so now we're on to interactively routing the board. It's talking about some settings you can do for that. I think the default settings are pretty good. Now it says time to route, baby. Okay, I am all for this. Okay. So for routing, and I can get in, routing is an art form, okay? It is what they pay people the big bucks to do. Okay? It is important. So what was I even gonna say? I got lost. So I guess one little tip when it comes to routing is the first thing you should do is just place all of the components. It's like a little puzzle. Okay, so I'm just dragging one component at a time and placing it. I mean, this board is extremely simple, so I wouldn't worry too much about it. Oh, I like that. Having, like, you don't have to employ any of these Pro League strats is what I'm trying to say. In order to actually, you know, get away with it with a decent design. Now, one thing I want to see. Ooh, okay. Alrighty. So I'm just kind of dragging around these components, placing them. I mean, it's a skill you learn. Like I said, I don't have a crazy amount of layout experience. So I actually don't know what these things are. I don't know what all this is. Like, this makes me uncomfortable, but I'm pressing spacebar again to rotate these around, bring them around where they need to be, so everything's nice and snug. Right, so that's kind of how I like things. So this might freak people out a lot. Like, oh my gosh, like it looks like just a giant clusterfuck. And I will say, do not worry, we'll get through it, okay? Okay, so one thing I want to do is check out. One thing I used to do is highlight the designator. Okay, there we go. So this designator belongs to this component, and so we're gonna line it up so that they know which component they're dealing with. This is important. These things are important to have some type of, make them easy to identify, because when you get the board manufactured, you're gonna have to like test it, and it could involve a lot of like looking around and trying to figure out where these components are. So that's why I'm doing all this. And then here, put that there, put that there. And we'll see, we'll scoot this in closer. Hopefully, I think we're gonna get an error if we do that. But I like, see, I don't know why it's doing that. Let's change our snap grid to 50 mil. There we go. See, now we're cooking. All right, back to 100. Okay, and then we want to move this one. Actually, we want to take this one 50 mils again. Actually, maybe we can go to 25 because, yeah. Because these things can't be too close. It's going to throw up some errors on us. Just want to make this line up like that. Okay. Okay. I think we're getting somewhere now. So, like I said, we have the components placed on the board. Now we can begin the routing process. So, like it suggests, we're going to do the interactive routing method, which is you just click route interactive. Not active, but interactive. Right? And I think I might have made a grave mistake. Or did I? I don't think I... No, I don't think I did. Okay, anyways, I think there's a... If you click R... Nope, that's not it. I think it tells you, actually, if you just go route. Interactive routing is Control W, okay? Control W. So we're interactive routing now. So boom, we click on that. Look at that, it looks beautiful. Let's change, this is when I'm fine with going with a smaller snap grid, right? Because I like these traces to look a certain way, like to have a certain, like I want to line up with the middle of that pad. And it's not, and I don't know why. But, there we go. Is that even, I still don't know if that's 100%. Okay, that looks right on to me. And of course, don't worry, these traces can go under, so like like if you see this is on the silk screen layer. So this is the tippity top layer. This trace is actually being routed under this. So think of it like icing on top of the cake is what this little silk screen thing is. So don't worry about the stuff that's going on under the cake. Just worry about the icing part. Or they won't ever, you don't have to worry about them touching each other. Like they're not, nothing bad's gonna happen. All right, let's hit that Control W again. Boom, there to there. I don't like that. I like that one better. And I'm just kind of going about, like, this is a very simple board, so, I mean, what you would do is, like, we can get into what I could call, like, PCB routing theory. We'll get into that in another video, but there's really only a few, I don't know how many major, there's only, what did it say, like, there's like 4 signals or so when we looked at the scope. I think there's only a handful of signal domains, so this is not that complicated. I do not know. Actually, this might be the last. I don't think we need to route this one anywhere. Okay. Ooh, this could be a problem now. Did that help? I do not know. I'm not sure. We might actually be in a problem right here. We'll see. But I could show you a Pro League move. Check this out. Oh, didn't know that. You can route between component pads. But you didn't know that, huh? It's a pretty nifty little trick. It's really cool. I thought it was the coolest thing ever when I first saw it done. But you can definitely do that. That is allowed, 100%. And I can't believe I'm giving you that secret move right off the bat. Like, it's almost too powerful for you to handle, honestly. So, oh, that's not what. See, I hit PW because I was used to that. shortcut. Okay. Now we'll click that. Okay, so now we got a route around town. So this is where things get a little tricky because right, we'll have this 3 different signals coming into this. Let's zoom in. Okay, so you can right click and drag when you're interactively routing. So we have 3 different signals coming into this component. And let me see, what is it? Oh, okay, yeah, that's, we'll worry about that later. We can honestly, okay, no, we're up on, we need to go up. So what I did was I clicked the minus button, I think. Minus button goes down a layer, plus button goes up a layer. If you look down at the bottom, oh, I wonder if I can turn off auto pan. Give me a second. I'll turn off auto pan. Tools, preferences, general, auto pan. Fuck the auto pan. If we want to quickly snap up and snap down a layer, you can do that with a if you're routing. So let's just go Control W and say I'm like routing this trace, and I want to go. I'm like, oh no, I'm going to run into something. I need to go down a layer. So boom, it automatically generates a via for you. So you can click, and then now you're on the bottom layer. So what that did. The reason I'm not doing that is because I haven't verified that the vias are the way that I want them to be, because. And I'm just clicking on this and delete. We'll talk about deleting traces and all of it. But vias are configured in here. Let me see. Is there like a printed electronics? I forgot. There's a place to define vias, but you'll see them all listed like right here. Where? Let me see if there's like a. Because it talks about routing already, so maybe I passed at the part where it's talking about defining a via. But defining the routing via style, it just says via style. Let me see if, let's just try this. So we'll go here, we'll go up a layer, click. Okay, I'll just leave that the way it is. Now we'll go over here. Now, see, I would have expected a via to pop up right there. I want to know it. I want to know its secrets, right? Full stack, top and bottom, simple. So talking about the diameter is 1 millimeter, hole size is 0.6. So it looks like it's just going to our preferred standards. But in a real design, you might have multiple. You might have multiple different vias that you configure for different situations. Especially if you have a multi-layer board, you'd have vias that go, connect from, say you have 4 layers, and you have a via going from layer 1 to 2, layer 1 to 3, or layer 1 to 4, 4 to 2, 3 to 1, 3 to 4, all a whole bunch of different things. There was a way to add via. I forgot how to do that. Like it's very simple. Layer stack, presets, no measurement. Create via types from used vias. We'll say yes. I don't know. Okay, I don't know what I just did, but insert layer above. Nope, that's not what I wanted to do. Oh well. I feel like this is, I need to show that part. I need to figure out how. Let me just find where it's talking about vias. He wants a test point? No. I mean, we see the via here, and it's just not on the layer stack manager, which is kind of where I like to see them. That way, you have like a whole list of all the vias you have to choose from, because I think what it's talking about is the template. You can define them. You can define them on like a per case basis. I mean, we're not. I don't even know if we need to use any. So we'll see. Alrighty. Ooh, we could have an interesting predicament here. See, we could have to go underground. Yeah, we'll just get that. We'll just drop a little via, go whoop. Oh, see, but then we have to use 2 of them, right? Because we have to go back up right here. And we could violate a rule. Oh, wait. Let's go back. See here how it's moving it out of the way. Wait. Let me go to the top layer. Alright. We just go back to here. Very awkward. Okay. Just save. We'll just do file. Save all. That saves everything for you. Alright, so our board is technically... No, it's not on. We still have the ground that we need to connect to. Control W. Okay, so now everything's saved. Just routing tips and tricks. Okay, let's see. Shift H. Control W. Shift H. That's supposed to like. There we go. So this is a real cool little thing. It shows you how close you can get before things start getting pushed. I just hit Control W and then Control W again to bring up that little thing. It mentions it in the feedback for interactive routing. Okay. So modifying, reroute an existing route. Okay. Because we did go under the board a little bit. I know ours doesn't look exactly like the tutorial, but that's okay. We're going off script. Let's see, rearrange existing routes. Dragging tips. Okay. I don't think you can explore I would say explore the rearranging existing routes and the modifying and rerouting existing route section on your own. Maybe I'll cover that in like another video or something. But yeah, because the part, okay, so I'm on the part now where it says active route, automated interactive routing. So this is completely useless. Okay, I should say that, not completely useless. This is really dumb. Okay, like if you just heard me say a few minutes ago, there are entire professions dedicated to doing this thing. Okay, if you could solve your routing problems with something as simple as one button, right, or one button press, and boom, all your routing problems are solved, like, you wouldn't need people whose entire jobs are focused on this. So I mean, one thing it's useful for is you click it and it ensures that the routing is possible, right? Because there could be the configuration, you have the component set in that the routing isn't possible, and that's very useful to know right away. But they don't even begin to think that it does even like an above average job of routing. Okay, so I think it looks like you can just do auto route all. We'll see what it does. Okay, route all. I don't know what this means. I've literally never used this auto route thing. Okay, so just tell us what it did. Did it change? Okay, so it did change. It did a little bit differently. So it did use a via. Let's see if we can control. Okay, so that's what it did. There you go. So if you see, I am just barely. I won't say better, but I'm almost as bad as the computer, I guess, based on the fact that I just said computer routing is bad. My routing's almost as bad. I actually don't even know if they. He literally just straightened out some route. Like, that's so dumb. Okay, well, I'm gonna skip the active route section. Okay, PCB editor allows for rule-driven design. Yeah. So what we're gonna do now is, what is it? No. Design? No. What is it? Design rule tools. Design rule check. This is where we're gonna get all those errors thrown back at us, and make sure. There's no way I did that. There's no way I'm that good. Okay, that's not what I wanted. Okay, so I see no. We'll do reset error markers. There we go. Design rule check. Run design rule. Okay, there we go. Okay, I was like, no way I got no errors. Okay, so here we go. This is the part that probably is very scary and very overwhelming to people. But don't worry, scary and overwhelming is my specialty. So we'll read this. Minimum solder mask sliver constraint violation. So let's just go. I double clicked on that. There should be a way to. Oh yeah, we can go this and we can see all that. We should be able to see all the errors. It's not really showing us any. Right. I'm gonna move the messages off to a different thing. What is this? All right, so I think that preference came back to bite me in the butt with. I think it's system. Wasn't navigate? Yeah. Right, because I'm not sure exactly what it's talking about. So one thing about it zooming in all the way is you're definitely sure what it's talking about. Okay, so like boom. Okay, so what it's saying is silk to solder mask clearance less than 0.25 millimeters. So okay, so the silk screen to the solder mask clearance is, so what's saying is this little yellow thing is too close to this purple thing, and if there's anything I learned in engineering, it's whenever we have a rule violation, the way you solve the rule violation is you just change the rules, baby. So that's what we're about to do. Silk to solder mask clearance constraint. Okay, clearance. Silk to solder mask. There must be like a. Where is this rule located at? Silk to solder mask clearance constraint violation. Okay, so I would think it's in clearance, but that's not what it's talking about, because these are not electrical things. This is solder mask expansion. Say placement. Manufacturing. Silk to solder mask clearance. So it's a rule we have not got to tamper with yet. So is pad. Oh, so right now it says 0.25 millimeters. Okay, we're just gonna crank this puppy back a little bit. Okay, we're gonna hit apply. So all these silk to solder mask should go away. Right, we're gonna hit OK. We're gonna go to tools, design rule check, run design rule check. Okay, boom. Oh wait, you can't see. Okay, there we go. We have much less violations now. Okay. All right. So next thing we're gonna do is the minimum solder mask sliver constraint violation. So what that's talking about is how do I? It's probably better if I explain it in 3D. So what is going on? Oh, look, now we can look at it. Cool. That's pretty nice. I think we did a good job with that component, honestly. It looks like what I thought it would look like. So what it's talking about is, and it's where the rule violations probably occurring is, okay, so the way I think I like to describe it is the solder mask. Think of it, if you've ever seen in the movies, maybe done this in real life, they have like the face masks you put on where you like cover your face in some type of like, it's like black, like waxy or liquidy thing that dries up and it's like does stuff for your pores, and you know, like the spa thing in movies. So think of that like your mask, right? And what it's saying is there's all these tiny crevices in your face, right, where you might only have like the space. Think about like the corner between your nose and your eye. Like do you want, like, if the mask getting in between there is like a tiny little sliver of mask. And what it's trying to say is we do not want the tiniest sliver of mask to be, we don't have to get really, really close in between all the lines, is what we're saying. It's very difficult to do that. Hopefully that made even a little bit of sense. So what I'm zooming in is this little part right here. So what it's saying is the board, like right there, see right there? That's the little crevice in between your nose and your eye, is what I'm trying to say. Is trying to get the mask to get up in there and like coat it properly. It's like trying to paint between the lines. You know, these lines are very narrow and you have barely any space. And they're saying, look, man, don't make us do that. It's not fun. We don't like it. Okay, we mess up a lot of boards doing that. Okay, so that's what that rule is talking about. Where do I go back to where's the messages, right? So that's what this rule is. Minimum solder mask sliver constraint violation. So it's talking about, this is a little bitty sliver, and maybe we can even zoom in on it. Okay, this is, yeah, so it's talking about same exact concept for under the board, I think. Let me see if I can find, because it should be talking about the one at the specific one I pointed out as well, right? Because it's even, does it say what net it is? Oh, it should say what net it is. Nope, it doesn't give me any help whatsoever. So we're going to the bottom one. Okay, where? Oh, exactly where I was talking about. What do you know? Okay. So that's what I was trying to say. Hopefully that made some sense. I'm saying is this little sliver, they're like, we don't like it. It's really hard to paint in that lane. And it's not actually, I don't know how they put on the solder mask, to be honest, but just think of it like painting. Okay, like we got to paint the board a nice fresh coat of paint, and we don't have to paint these tiny little lines, so just stop making us do it. So like I said, the best way to get rid of these, okay, I'm saying the best way to solve these problems is just to ignore the rule, but in real life, we'll explain how you do it differently. What you do is you set it up to where they just didn't paint, it was just bare copper between that space. There was no solder mask, but the way we're going to do it, and I think the way Altium, I think that the way the tutorial says to do it is, because it's pretty complicated to set that up. The way the tutorial says to do it is just to change this, right? And one thing I want to say is I don't know that this value has any real meaning right now. Like in order to figure out what the real life value is that they can't paint between the lines is, you can go to the manufacturer's website and they'll tell you. So I don't know if this is actually a problem, is what I'm saying. So it could be the case that this is not actually a problem. You don't really come into, you don't really have this problem a lot. So that's another point I want to make. It's not like all the problems that are showing up right now could just be a fact of us not tweaking our design rules to begin with. So let's just try the old run design rule check. What is it saying now? Oh, it's 0.17. Okay, so it's even smaller than that. I put it at 0.2. It needs to be 0.17. All right. 0.17 it is. 0.17, baby. All right. Alright, now let's just do this whole thing again. So you get really good at this whenever you have to do it over and over again. And that's the key. Repetition's the key. And it's doing it again. Why is it saying 0.17 is less than 0.17? I don't even know why that's... Okay, we gotta try it again, I guess. Maybe it's design rules 0.16. Okay, now let's try it again. And it's still giving us to us. It says 0.17. That's why. Man, I'm off by a whole decimal place. That's not good. Okay. Alright, we'll change it to 0.017. 0.017. Okay. I don't know. I'd be surprised if they can actually manufacture that small of a sliver. Alright, run design rule check. We should get blue. Oh my freaking gosh. 0.017 millimeter, less than 0.017 millimeter. Alright, so let's... Or we'll try again. Alright, we'll say 0.016. This seems oddly familiar of a process. Like, I feel like I did this the first time I did this project a while back. It's always good to go through it again. There we go. Okay, no errors. Only took us like 5 tries, but hey, that's engineering, baby. Okay. So, yeah, we struggled through that part. Configure display the rule violations. Okay, so yeah, we can do that. Let's see, PCB editor, dear. PCB editor. Preferences dialog. So it's just tools, preferences, PCB editor, and it says DRC violations display. So that's what I was talking about. Is you can have them like this or like this. I mean, it doesn't really matter, honestly. And errors and errors. So like, I wouldn't worry about this. Okay, so I think it's gonna show us how to solve the problems in a second. Cause we already have run the DRC. So we ran the DRC. So we had 17 violations. Well, okay, in the error condition. So yeah, like I said, double click in the message panel. And so you can also double click in here. Right now we have 0 violations, so this is what you want to see right here. Perfect report. Just the way we want it. So, yeah, I'm just gonna scroll down. I want to see what they did, how they solved that problem, because I think they did the same thing I did. Yeah, so trying to save that. There you go. Yeah, so it actually ended up doing what I did. Okay, I haven't actually read this whole. It should be obvious that I haven't read this because I don't seem like the type of person to read. Okay, or I barely know how to read. So yeah, they did kind of what I did. They just changed the one for that through hole pad. So that's supposed to just cover that constraint. I still think there should be a better way to do it because through hole to through hole, you could still have cases where they don't belong to the same component and then they're too close to each other. So I don't think nothing is magic about a component being through hole and making it okay to be closer together. That's what I'm trying to say. So again, yeah, it seems like they just go through and change everything. So yeah, now we can see it in 3D. Like I said, our connector looks a little bit different than theirs because we chose a different one. I'm still happy with the one we chose because I just thought it would have been really bad. Oops. Now we wanna. Nope. There we go. There should be, okay, I think there's a way to, what is it? There's view, and there's like 0 rotation, and that kind of like sets it like this again. So yeah, like one thing I want to point out, well, it already changed these, so you can't really see, but like maybe right here in this corner, you can see how this is over the top of this trace. That's okay. That's totally fine. You can see the pretty little traces. They're like little ant farms. Okay, Since we're working in 3D, I don't really work in 3D. I mean, you work in 3D. I actually don't know. I mean, 3D is a good way to explain things. Like, say you're working on a team with mechanical engineers or other people who need to see the board. This is a great way to show things to them, right? Because they really don't care what the routing looks like. This is a great graphical way to explain, what the board looks like, right? I think that's what this is most valuable for. It's just a pop back in and out between 2D and 3D. Okay, cool. So that was honestly, it was probably really rough on y'all's end. I'm really sorry about that. It is what it is. But yeah, that brings us to the end of the PCB routing section. It was probably does just as long as the schematic section, which honestly, I mean, when I first did this, it took me like several days. So we're actually making pretty good time. It only took, I skipped over a bunch of stuff, but yeah. So just read that stuff. Like I said, read anything I skipped over, which I skipped over a lot, and I mentioned the stuff that I think matters as well. But yeah, so the next part is going to be the output documentation part, which is a really cool part because it means you're coming to the end. Like your board right now, our board is designed. It's passes all the design rules, so technically you can get it manufactured if you really wanted to. So you should feel good about that. Honestly, it's actually a milestone you've hit in your engineering career if you can do this. Even if it's a simple board, like just be happy. Like the software is very complicated. Getting through it is an achievement, right? Because once you use this more and more and more, you'll get better and better and better. So let me see things to leave you with. Yeah, like I said, leave a comment down below if there's any questions you have, anything you want me to cover in the future, any like project ideas you'd have for me, because I will eventually. My plan is, I was planning on having different series of videos. So one is gonna be like Altium tutorials, right? Like I'm already planning a video where I'll show you how to do component footprints and do all types of component stuff. Another one I was planning on actually showing off some of my own design projects of things I work on my own, because I mean, in order to be a good engineer, you got to continuously work on projects, even outside of work. If you want to sharpen your skills, you got to pick your own projects and you got to work on them. And so I was just going to show off some of that stuff, right? You can't really show off stuff you do at your company because you like sign NDAs and stuff like that. So it's not a good idea to do that. So which makes it kind of hard, honestly, which makes learning in the engineering world kind of hard, because basically I have to design a board for free in order so I can talk about it with other people, so I can actually communicate with an engineer outside my company and have a much larger network of people to like talk about and learn from. So that kind of sucks. So that's kind of another reason why I'm doing this. Is I just want to have a place where people can talk about electrical engineering and we can get nitty gritty down to the details. Talk like I can literally share with you the files of this project, right? So that's another thing. So yeah, like I said, any questions, suggestions for how to make these videos better? Like I said, this is coming on like an hour long, so I mean, plus I did a pretty rough job on that stuff. Like I said, you should be more scripted or more prepared. Like I said, I kind of just wang it off the cuff here. But this is like the tutorial where I'll be more scripted whenever I actually do, like, in the future and stuff like that. So yeah, that's pretty much what I guess I'll leave you with. So yeah, if you made it to the end of this video, thank you so much. I really hope it helped you. I really hope it helped somebody get through this. So yeah, thanks.